Video, I'm going to demonstrate how to perform cluster analysis on JMP. For demonstration purpose, I have taken HBAT 100 data and we are going to perform cluster analysis on 100 observations. The variables that I'm selecting are all continuous and from x16 to x18. To perform cluster analysis, select these options: analyze, then clustering, and the first method that I'm going to demonstrate is the hierarchical cluster. Now select the data variables and put them in Y column. Here you can select the appropriate method of clustering. I'm going to, for demonstration purpose, I'm going to go with the complete linkage. You can also standardize the data, and JMP asks you whether you want to have the standardization by rows and column also, or just no standardization at all. So here I'm going to standardize it by columns and then click on OK. JMP will generate this hierarchical cluster tree, and using this diamond you can change the number of clusters. Now under this right triangle you can select options such as mark cluster. So every data point to whichever cluster it is allocated, it will be marked. Under this right triangle you can also choose this option of coloring the cluster for easy identification. And cluster criterion, you can look at CCC criteria for optimal number of clusters. So you will find many options here. And if you click on save cluster, the number of the observation to which cluster it belongs to will appear here. Now by changing this red triangle you can by sliding this red triangle we can change the number of clusters. Let's say if I keep number of clusters 8, then all the different clusters will be marked in the same color by different colors. And how many cluster to keep, it all depends upon some subjective decisions and objective decision. One of the objective or quantitative decision that we can look here is on the distance graph. So distance graph here tells you that how much the clusters were dissimilar when they were joined together. Let's say I had previously selected 20 clusters. Now from 20, or let's say 20, I made 19 clusters. Basically I combined two clusters and therefore the resulting number of clusters are 19. Now look at the blue line here. The increase in the slope of the blue line is almost horizontal, not very significant slope is there. So it means that the number of the clusters which it joined together from 20 to 19, the two clusters which it joined together so that the number of clusters were reduced to 19, those clusters were not highly dissimilar. They were kind of similar clusters only. So for example, here, let's say I decide 6 number of clusters, and if I change it to 5, now you see from 6 to 5 it had to join two clusters so that the number reduces from 6 to 5. And when it joined two clusters, based on the criteria, the distance between those clusters was quite high. Actually the dissimilarity was quite high as previous to the example which I shown you, because if you see the slope of the line here. Now similarly we can observe the same thing here. From 5 to 4, if I have 5 clusters earlier, now I change it to 4. So the two clusters have to be merged so that the number becomes 4 from the 5. So when it merged two clusters, they were quite similar. That is why this line is flat. And from 4 clusters to 3 cluster, again it had to merge two clusters so that the number decreases to 3. As soon as it does that, it has to merge two clusters. So those two clusters distance is actually higher. That means they are quite dissimilar. So here the idea is we keep those observations which are similar and keep those observations different which are dissimilar. So here I can take an approach that 4 number of clusters are appropriate, because if I further reduce it to 3, I will have to merge those clusters which are actually quite far away, which are dissimilar. So such kind of decision criteria can be taken in hierarchical clustering. And once we are Okay, on this, once we decide the appropriate number of clusters, you can click on again save clusters, and you will see that the number of clusters have appeared here. I will delete the previous number of clusters which were added. Under this red triangle, you can also change the options like cluster summary. I mean, look at the options like cluster summary. It will show you that what was the variable mean in each cluster. Cluster mean, let's say in first cluster there were 26 number of observations, what was the average value of x6 cluster, and you can take appropriate decision based on that. So this is how you perform hierarchical clustering in the using jump. Now the second type of clustering is the k-means clustering. For k-means clustering, so for this purpose I am going to uh, remove everything from the data. So control A, whatever we have done till now, yes. So again I am going to select the same set of variable which are x6 to x18. Now instead of hierarchical clustering I am going to perform the k-means clustering. So you can find k-means clustering here, again in analyze and clustering, and it will also scale the columns, basically standardize the column, and which is a requirement for clustering. Now here it asks for what method to be used. So the method is k-mean cluster. Now it is asking what is the minimum number of clusters you want. So in case of hierarchical clustering, it will first it's a top-down or bottom-up approach as per the software. From this approach differs for different software. So there we decide the number of clusters after generating that tree. In case of k-mean clustering, we need to decide the number of clusters beforehand, a priori. So let's say the number of clusters I am saying 2. Okay. And then click on go. Other options you can explore on your own what they do. So it's only related to the calculations, nothing else. So with k-means 2 clusters, it has divided the observations into appropriate number of clusters. Now if you click on this red triangle, you can click on save cluster. So this column has appeared here which is telling you that to which cluster these observations belong to. Scatter plot matrix that you can do from this basically clustering. And again what you can do is you can look at the k distance formula, save cluster distance and all those things, or you can also save colors to the table, so it will tell you that which cluster it belongs to, the observation. You can click on by plot, so which observation belongs to which cluster, that will appear here. And apart from that, the mean of each cluster will appear here. Cluster standard deviation, what is the variability in each cluster, that will appear here. One more option that jump gives is, so again I'm going to clear the all row states. I want to fresh start my analysis, and I'm going to delete the existing results, x6 to x18. These are the columns that I'm going to use: analyze, clustering and k-means clustering. Now suppose if I want to try with different number of clusters, because in hierarchical clustering it is very easy, you just drag that diamond shape to left or right. So let's say the minimum number of clusters are 2 and maximum number of cluster I want to try with 10, and based on that I will take the decision. So click on go, and here you see that for 2 it has fitted the cluster model, for 3 cluster it has fitted the cluster model, for 4. So usually if I see that here the uniformity is kind of okay, in these cases one of the cluster has lower observations, in this cluster again this kind of uniformity. So there are certain guidelines which will tell you that uh, what number of clusters are appropriate. So by generating these all possible number of clusters, you can take a decision that what is the best number of cluster that your model should have. So that is how you fit use the cluster analysis to cluster the observations into appropriate number of clusters using jump.